Hello everybody and welcome to my new SQL Server Quickie. In the last Quickie I have talked about the hash join operator in SQL Server, and today I will cover a performance related topic. I will introduce a concept called tipping point to you, and you will learn why that concept is very important for performance tuning. In a nutshell, the tipping point defines whether SQL Server performs a so-called bookmark lookup or performs a scan of your complete table. Let's switch over to the flip chart where I will describe the tipping point in more detail to you. I want to show you now with a very simple demonstration on the flip chart why we need the so-called tipping point in SQL Server. Imagine we have a simple query, select star from a table T where column CX equals something. We have defined a non-clustered index on our search predicate CX. So in that case, maybe SQL Server is doing a non-clustered index seek, non-clustered index scan, and because of the select star query, we need additional columns which are not part of our non-clustered index. Means SQL Server has to perform a bookmark lookup operator, and both operations are joined together through a nested loop operator within our execution plan. The problem that we have now is the following. Imagine we're retrieving, let's say, 500 rows through the non-clustered index. We're producing here some page reads, and now we have to perform that lookup 500 times. So in our case, when we have a clustered index, SQL Server has to perform a clustered index seek 500 times. Means when our clustered index has a navigation structure with 3 levels, which is almost always the common case, we need here 1500 page reads. We need some page reads for accessing our non-clustered index. Let's say we're performing here a partial range scan to get those 500 records. Let's say we need here 200 page reads. So in sum we have 1700 page reads. At some point in time it can be more economically to discard that execution plan and just perform a complete scan, clustered index scan of our table, and just discard non-qualifying rows through a residual predicate. And that point where SQL Server makes that decision, doing a bookmark lookup or performing a table or clustered index scan with a residual predicate, that's the so-called tipping point in SQL Server. And the tipping point is based on the number of pages that we are reading with our query. The tipping point is somewhere between 1/4 and 1/3 of the pages that we are reading through our execution plan. Let's switch now over to SQL Server Management Studio, and I will show you with a concrete example what the tipping point is and how the tipping point looks like in SQL Server. In the first step of this demo, I create a new database, and within that database I create the table customers. As you can see from the table definition, every record is exactly 400 bytes long. Therefore, we can store up to 20 records on one page of 8 kilobytes. In the next step, I create a new clustered index on that table. After the creation of the clustered index, I insert 80,000 records in a simple while loop. After the insertion of the records, I create a non-clustered index on the column named value. This means that we will get a bookmark lookup in the execution plan when we query for this column and request additional columns in the select list of the query. When we perform a simple select query against the table, you can see that that query produces 4016 page reads. Our table consists now of 4000 pages in the leaf level. This means that our tipping point is somewhere between 1000 and 1303 pages. The following query retrieves 1061 records. When we look at the execution plan, you can also see that the query optimizer has chosen a bookmark lookup operator. When we look at our page reads, you can see that this query already produces 3262 page reads. SQL Server has to perform the bookmark lookup for every returned record. In our case, the bookmark lookup is performed 1061 times for every record, over and over and over again. The more records your query returns, the more page reads you have to perform. That's the reason why SQL Server has to introduce the concept of the tipping point. When we now run the same query again, and when we return one record more, in our case 1062 records, things are changing completely. SQL Server now scans our whole clustered index in the leaf level, because our query is now over the tipping point. And when we have a look at the I/O costs, we are back at the 4016 page reads. You now have one of the biggest performance problems in SQL Server in front of you. You have executed two almost identical queries, but you got two different execution plans from the query optimizer. Depending on the selectivity of your query, you are getting back a different execution plan. With a selective query, the query optimizer chooses a bookmark lookup. And with a non-selective query, a scan of your whole clustered table is chosen. This behavior will have really awful side effects if such a plan is cached and afterwards blindly reused by SQL Server. We will cover that specific problem in a later SQL Server Quickie. To prove that the number of records is completely irrelevant for the tipping point, I have created another table with the same amount of records, in our case 80,000. The only difference in the table schema is that every record is only 40 bytes long. Therefore, 200 records can be stored on one page of 8 kilobytes. The leaf level of the clustered index consists therefore of only 400 pages. When we do the math, the tipping point is somewhere between 100 and 133 pages. A complete scan of the clustered index in the leaf level costs us 419 page reads. I now run a query that returns 156 records through a bookmark lookup in the execution plan. When you look at the page reads, you can see that that query already needs 332 page reads. That's a lot compared to a complete scan of the clustered index. When we now return one more record, the query tips over again and SQL Server scans our whole table. But imagine, you have now returned 157 records out of 80,000, and SQL Server ignores your almost perfect non-clustered index. Except that it's not a perfect non-clustered index, because for that specific query, it's not a covering non-clustered index. In conclusion, we can say that a non-clustered index, which isn't a covering non-clustered index, has a very selective use case in SQL Server when you are dealing with very small records, as in a typical OLTP environment. To prove how badly bookmark lookups can be, I'm returning now all 80,000 records from that table through a bookmark lookup. I'm just hinting SQL Server to use the non-clustered index. When we now look at the page reads, we will see really crazy things. That query now produces 165,142 page reads. It's almost 400 times worse than a complete scan of the leaf level of the clustered index. Imagine what happens if such a plan gets cached and reused over and over and over again. In this SQL Server Quickie, I have shown you the concept of the dipping point in SQL Server. As you have seen, the dipping point defines whether SQL Server performs a bookmark lookup or performs a complete scan of your table. The most important point to remember is that the dipping point is somewhere between 1/4 and 1/3 of the pages that your query reads when you perform a bookmark lookup in the execution plan. This also means that the number of records is completely irrelevant for the dipping point itself, as you have seen in the demonstration. The smaller your records are, the more records fit onto one page of 8 kilobytes, and the less records you can read with a non-clustered index that produces a bookmark lookup. I hope that I have gave you with this SQL Server Quickie a good understanding of the dipping point in SQL Server. In one of the upcoming quickies, you will also see how the dipping point can influence plan caching in SQL Server and how it can produce very bad performing queries. Stay tuned and thanks for watching.